Sounds good.
Hey everybody, this is group 4. We're doing our final presentation here. The data set we chose to use was the car price prediction data set. Our group is Jadozi, Jason, Haley, and myself. For the purpose of the analysis of our data, why we chose this file, um, technically, by analyzing the data in R, we can we can learn how to predict the cost of a car using different factors taken from the data set as evidence to use in the calculations. The data set's pretty big. We didn't, it would have taken a very long time to make accurate calculations if we went with every individual facet within the data set. So we chose what we thought were the 5 most influential columns within the data set. You can see the body type of a car, the fuel type of a car, the number of doors of a car, the curb weight of a car, and the horsepower of a car. Now, by understanding how each of these different columns works within a data set, we can look and see what the relationship they have with one another is. Um, Things such as how does a car's body type relate to its price? There are multiple car body types present within the data set, such as a hatchback, hardtop, convertible, sedan, and wagon. With so using this model to predict the data, we can look and see if say a sedan or a wagon has lower prices to buying a car than say maybe we can look and see if a convertible is the most expensive type, or if a sedan is the most expensive type, or we can see if a wagon is the cheapest car. You can look at other columns within the data set as well, such as curb weight. We can look and try and by analyzing the meaning of the data, see if a higher curb weight correlates to a higher overall price, or if on another front, if the cars with the highest horsepower are on average the highest costing ones, or similarly, if a low horsepower almost or if a low horsepower means that the car will generally have a low selling price. So this here is a basic summary of the data. It shows everything from the data set. Obviously, we didn't use everything from this as the column that we also used, not for calculations, but predicting against, was the price column, which is the last column on the summary shown here. And by using the data that we ran in our prediction model, the long-term goal is that ideally we can predict what in the future what prices will be higher, what prices will be lower based off of the rest of the calculations we made.
All right, thank you, Reed. So to analyze our data, we're going to start by showing you the box plots for some of the variables that we selected. And for this first slide, we are showing the relationship between the car body of a vehicle and the price of the vehicle. And here we see that on average, the price of a hardtop, um, you know, is going to be higher than the price of other vehicles such as convertible, hatchback, and sedan, as illustrated by the box plots. And here we are showing the relationship on the left side. We're showing the relationship between the door number of a vehicle and the price of the vehicle. Not a significant difference between those two, whether a four-door or two-door vehicle. However, we do observe that the price for four-door vehicles are um, slightly higher than the price for two-door vehicles. On the right side, we are observing that the price for diesel vehicles are going to be higher than the price for gas vehicles.
Thank you, Chidozi. To continue visualizing our data, this is just a general scatter plot of all of the variables that we selected. As you can see, we only plotted the variables that we selected instead of every single column, which is fuel type, car body, price, horsepower, and curb weight. The main takeaway from this set of scatter plots is that we found that horsepower and curb weight have a positive relationship with price. On this slide, you can see two of our three density plots. For curb weight, we have a skewness of 0.67, which means the plot is normal, and it has a unimodal distribution. For the second density plot, for horsepower, we have a skewness of 1.38, which means the plot is right skewed, and it also has a unimodal distribution. Density plots continued. This is our final density plot where we plotted price. It has a skewness of 1.75, which means it is right skewed, and it also has unimodal distribution. All of our density plots ended up having unimodal distribution.
Okay, I'm going to go over the steps that we use to find our multiple regression model. First, we identified our categorical variables to be used in the multiple regression model, and we determined that the categorical variables needed to be numeric variables that have an infinite number of values between any two values. After this, we converted the CVs to factors, and we used the factor function to convert the CVs to then be used for analysis. After this step, we inserted the factors into the original linear regression model for prediction.
So for our multiple regression model, we chose price. We are predicting for price as a dependent variable, and for the independent variables, we are using categorical variables of fuel type, door number, and car body. And for continuous variables, we have chosen horsepower and curb weight for our continuous variables. Now, looking at the slide to the right, the estimates there on the right side shows that for fuel type, gas when compared to diesel would be lower in price. For door number, two-door vehicles when compared to four-door vehicles will run slightly higher in price as well. For car body, in this case not shown, we are comparing to convertible. We show that hardtop will run higher in price when compared to convertible, and hatchback, sedan, and wagons will run lower in price when compared to convertible vehicles. For horsepower, there were no sub-variables, so this is a continuous variable. So on this one, we're showing that per every unit increase in horsepower, the increase in price is 71.487, and for curb weight, per every unit increase in curb weight, the increases in price is 8.572. Now, overall, when looking at all these different factors, all these different variables, it would seem the summary illustrates that the best predictor for price when looking at the p-value would be horsepower and curb weight, because those two variables were significantly below 0.05 in p-values. And our model overall, as currently created, is also a strong predictor for price, as illustrated by the adjusted R-squared at 0.8092. Now, how can this model be used. We believe that this model can be used in many ways. Could be used by car manufacturers in predicting what the price of a vehicle will be before they begin in the production of that particular vehicle. They could it could also be used by maybe delivery companies in figuring out what the best type of vehicle will be. Should the vehicle run on gas or should it run on diesel? And calculating the cost of those to see what the best decision would be for the company.
All right, so in the future, what could we use this regression model for? We could use it for refining. We could further refine the process to be more specific, adding in additional variables such as the dimensions of the car, the engine type, if it runs on electricity, the miles per gallon on city and highway. And then eventually the model could be fitted to work with inflation rates and be used to like predict further car costs in the future.
Very good. Well, thanks everyone for a great job on your parts, and this is where we'll end our recording.